So, my name's Zeth. I write Python software for a living mostly. I have done various things over the years with XML, and then a lot of the use case for XML seemed to get replaced by JSON. And wrote a lot of software that deals with JSON in various ways, just using whatever method worked for me at the time. Whatever was just working, I just stuck with that. But various people have tried to encode these into standards. So a lot of what I've kind of like, what I've accidentally come across, somebody else has specified better as a standard. And I thought an exciting or interesting thing might be to do would be to look at them and see which ones are useful and what happens. I assume you've already guessed what the title's about. Who's guessed what the title's about? Anybody? No? Okay, well if I called it JSON and the Argonauts, it would have been a bit more obvious. But another adventure with JSON is JSON. Wearing clothes was not that important in ancient Greek because it was really hot and it showed off your strength and so on. At least that's how they classically show it. But so Jason's uncle was Pelias, and he was the king of Thessalonica. And Jason kind of, or some people consider Jason the true heir, including Jason's girlfriend Medea. And she organised. Pelias was a really good king, well, not a good king, but really a military efficient king, and couldn't be dislodged by his nephew. So Medea told the daughters of Pelias that the real heir to the throne should be Pelias himself, and the way to rejuvenate Pelias would be to give him a new young body. And the way we should do that is to cut him up and boil him in a pot, and he would then re-emerge resurrected in a new young body. Pelias wasn't quite keen on this idea, so it's kind of one of those images of classical painting where Pelias is saying, "Get off, leave me alone, don't cut me up," to his beloved daughters. And the Greeks, the fictional Greeks or the legendary Greeks, were not so happy about their king being cut up, and Jason never did get the throne. So, the question is, one of the quick questions really with these of the talk is whether these kind of daughter standards of JSON are any good or not, or whether they take away the flexibility and the fun that is JSON. So I assume, who's used encoded some kind of data in JSON before? Put your hands up. Everybody. Who hasn't? No, but two people. Okay. So the next slide, just relax and breathe. So JSON is just a lightweight data format. It was encoded Internet Standard. It's everywhere. And if you're in, purists will hate this, but if you're a Python, just imagine it's a dict. You just shove all your data in it and encode it into text. Freeze. There we go. So JSON versus XML. JSON is used in lots of domains where XML was previously used. In the compromise between the human and the computer, JSON is slightly nearer the computer than XML. So I like to think of JSON as the Terminator, and XML is just Robocop. And obviously, the Terminator would win, wouldn't he? I think. And there's just one Robocop, and there are millions of Terminators. So XML has lots of established daughter standards and tools, like document type definition, XML schema, XPath, XSOL, XQuery, SAX, DOM, and the skills and so on. One of the things, the promises of XML is that it's a human-readable and human-writable data format that can also be understood by the computer. But it doesn't really work like that. If you've ever had any experience of non-programmers writing XML, whatever they produce, so I've got a lot of experience in a previous job where people were encoding manuscripts in XML, and there was a lot of fixing to make them actually validate as XML. And the computer doesn't really understand XML either. As a programmer, there was lots of like higher level approaches, like the ones that are listed in this line, to actually make XML easily understandable. So with JSON, it doesn't quite have that problem in the sense that it's not trying to be a human left-to-right language. It's kind of human readable as much as XML is, I think, but it's really easy for the computer to understand because it deserializes as a kind of native object in most languages like JavaScript and Python and lots of other languages I don't care about. One of these standards, so I'm just going to go through some of these ideas and try to discuss them. And it took like 10 minutes to get everybody out of the keynote, but hopefully you can give me your ideas as well. The first standard is called JSON Pointer. It's really simple. It's a syntax for retrieving any arbitrary sub-object from a JSON object. And it's just basically URL syntax where you obviously just separate the keys with slashes. All of these JSON standards don't really have a canonical Python implementation. It's just like if you go to PyPy and put in JSON, you just get millions and millions of things. A lot of which I think the most used, so there's some really good tools like Django REST framework and stuff that people are using JSON with. And so a lot of the tools are like, JSON schema for Django or JSON schema for this or JSON schema for that. So I'm just going to use kind of like pure Python implementation in this talk, but there are millions. JSON Pointer. So if we have a JSON document, so just kind of like a file or some other kind of serial stream transition method giving you some JSON is often called a document, and a document contains objects. And this is like the heroes equals makes it a Python dictionary, but otherwise it's a JSON object. So imagine we have an object called robots, and in it there might be different kind of robots, but I only really care about transformers. And we have Autobots and Decepticons, and Autobots and Decepticons are organized into sub-teams, such as the Rescue Bots and the Seekers. So the normal Python access is just you say, give me the first rescue bot that's inside Autobots, that's inside Transformers, that's inside robots. JSON Pointer is almost the same. So you say, give me the first rescue bot inside the Autobots, inside Transformers, inside robots. Very much common sense. Why bother? Well, it kind of builds upon this, as we will see. So the next thing is the JSON reference. So it's just basically the same thing, but with the word ref as the key and the JSON pointer as the value. This allows you to refer to different documents inside your JSON. So it's actually quite useful. Here's an example. So there's a nice library called JSON Spec, which has a lot of these JSON tools in. I don't think it's the most efficient library, but it's good for doing slides with because it doesn't involve opening Django objects or anything complicated. In this simple example, we have a JSON pointer here, robots, transformers, Decepticon, seekers, and then we refer to an external JSON file within a piece of JSON. In this library, there's different providers, like a web provider or a file system provider, and I'm providing it in a file. So this piece of JSON is referring to an external file, and I can then, when I resolve this piece of JSON, it will translate test heroes, robots, transformers, Decepticons, seekers into the actual object, and I will get out the third transformer from the list of rescue bots inside the file. Simple so far? Yep. The next thing that builds on top of that is JSON schema. Who's used JSON schema? Wow, loads of you. Who's never heard of JSON Schema before? Wow, good. I was about to go for a cup of tea. Great. When you're dealing with JSON, if it gets complicated, rather than have millions and millions of try excepts, you want to kind of know at a certain point in your program what the actual data format you're dealing with is. And I found most people end up doing something like oh, I haven't got it open. Most people end up doing something like this, which is implementing your own validators. This is how I came onto the subject. So that's what I did. I ended up implementing my own kind of Django-like field names. And if you look at lots of people who do this kind of thing, they just validate their own JSON as they go along. But JSON Schema is an attempt to make a standard of it. So it's very simple. It's all gone small. Can you read that at the back? So it's very simple. You define we'll start from the bottom. We've got a member of the object called properties, and you have various properties, and then you say which properties are optional and which properties are required by saying which are the required types. So for this object, an instance of this object has to have a name, an out mode, an age, and a team, and all these ones are required, but they could be optional. So it's simple to validate that. We simply just open the schema up in Python, and but in a real application, it might be coming from somewhere like the web or from some other process. But for this simple example, we'll just open it from a file. Then you have an actual instance defined, to be validated against that schema, and then we literally just tell the schema about the object, and if it doesn't throw an error, it has been validated. More complex schema. So this is a schema for an FSTAB entry on a file system, and the interesting bit is some of the schemas can get quite wordy, but the interesting bit is this bit. So to try and make your schemas and your data objects a bit more less hairy, you can refer to other schemas using a JSON reference, which we just explained earlier. And when you start doing JSON schema, you find JSON references everywhere. So this one is saying an FSTAB entry, so a disk on a system, has to be one of these kind of things. It has to be, thank you, a disk device or a unique identifier or a network file system or a temporary file system. And then for each of these, there's no domain name and no file name or anything. So it's internally referred to. It's an internally referred to subschema. And if you go down, you'll see that each of these are then defined. So as you can see, you can make it really fun. You can make, you can require, rather than just require a string, you can require things have to be a certain pattern. You can require that numbers have to be maximum 512, a minimum 16. So you can basically validate all your entry through JSON schema. Has anybody heard of JSON D? 1, 2 people, 3 people. Okay, so some people didn't like JSON schema and tried to create JSON D. I didn't actually like JSON D, so I was interested to see who's coming to it. So instead of putting these extra requirements as kind of more long-winded patterns and extra keys, it's very much more simplified approach, where the actual keys of the field names have it included. Those definitions of the fields have it included. So in this case, It can be any number from 18 onwards. Yeah, it's interesting that most of you have heard of a JSON schema. That's good. I prefer JSON schema, but they're competing standards. JSON linked data. Has anyone used JSON linked data? Did you have any luck with it? Hang on one sec. Have you got can you run a microphone? Oh, am I just talking with my own voice? Can you hear me at the back with my own voice? Okay. Oh, okay. It's not making any noise.
I've not used it heavily, but I'm never sure. So I've not used it much, but I've mostly just had to deal with linked data systems, so I've just been consuming it mostly as if it was normal JSON. Right. But I'm kind of aware of it and how it works, and
yeah.
that dealing with it properly is, well, you need to load it into something that understands triples, which is a very different way of working with anything.
Yeah, yeah. Of course, thank you. Is the other person? Does the other person want to say? Where's the other person? Can you get the mic to them?
I use it all the time. I use it as a standard response format for APIs that are self-describing. I work with a lot of systems where I want the freedom to evolve them separately. So using off-the-shelf JSON-LD libraries to provide the semantic objects of what I'm talking about lets me write code at a higher level so that I can actually change the structure of responses for one service, and the consuming service can tolerate that a lot better than you would get with just vanilla plain JSON. And the reason I liked it so much is because it's kind of backwards compatible with what people think of as vanilla application/JSON. So people who don't understand it don't have to. They can consume it like they would with JavaScript. But it is a sort of very rich hypermedia RDF type format, so you get the best of both worlds, in my opinion.
Great, thank you for that. Great, thank you for that contribution. Yeah, I don't know. I find it really quite hard. I mean, that's what my opinion of JSON-LD was. A bit of a dog's breakfast. Because once you, this is quite a nice example, but a simple example. Once they get complicated, the easy to understand nature of the JSON breaks down, but maybe your use case is a bit more. People understand the data set really well anyway. I don't know, but if you're not used to linked data in RDF, it's basically RDF in JSON. It doesn't really. I don't think it really accepts the model of kind of key value storage as who's used JSONRPC? Oh, quite a few. Quite a few. Anybody want to say a comment about JSONRPC before I explain it? Where they've used it? Well, as the mic's going to you, I'll just explain it. Put your hand up if you want to say something, how cool you've used JSONRPC. No? So all you used it, didn't make anything cool with it. Okay, yes. Yeah.
Hi there. JSONRPC is a really simple way of shipping JSON blobs in a standard way and getting a JSON blob in response.
Yeah.
So very easy to use, lots of Python libraries.
And how did you use it?
For an internal API service, which actually had to run through a JSON schema as well.
Yeah.
So yeah, validated RPC service.
And did you find they combined well?
Yes, yeah, I found it was really straightforward.
Yeah.
So yeah.
Yeah. And out of interest, did you write it all yourself, or did you use any library?
Yeah, we use some Python libraries for that.
Do you know the names?
I can't actually remember the name of them off the top of my head. Sorry.
Okay.
JSONRPC, yeah.
Yeah. Okay. Just something random from PyPy. Yeah, I want to have that. Thanks. I want to walk. They just turn it off when I use it. I just shout too much. So yeah, it's a really nice, lightweight procedure call protocol, and as the audience member said, I think it fits really nicely with JSON schema. It's got three parts to it: the methods, the params, and the ID. This is very JavaScript thinking. you send basically the method and the arguments that you want. So the method could be getPut, but it could be also any method you want, any method you understand. And the response has to be a result or an error. But also, you have to send through the ID of the request. And I've never found in any Python library anybody that does anything with it, because normally in Python you either have an asynchronous process like Tornado or Twisted, or you have, it's just a synchronous program. And in any case, you tend to know what you're putting in and what you're getting out. So I think the idea of the ID is that you kind of basically get loads of requests in and you don't know what they are, so you look at the ID to figure it out. I never found that to be useful, but it's quite useful for if you've got like a long string of callbacks, like in Tornado, then you can actually abuse the ID to just put in any other information that you need to process that result, and that's quite interesting. I lost 10 minutes because of that thing. Okay. Anyway, the request is, as you say, you get a request, you get a result, we don't talk about that. So there are also quite nice serialization formats for JSON, but I've been timed out, so you got the first half of my talk anyway. So thank you. That's the end.